All right, we should be live, and I'm sure we're going to have some attendees popping on. So let's give it a minute. Welcome anybody who's watching us here. I'm glad you're joining us today. As you can see, it's a beautiful day here. That's my background. But yeah, it looks like people are coming on here, and we'll just give it a minute. I know how it is trying to load onto these things, technologies. We love it, sometimes we love it, sometimes we hate it, but I am kind of excited for to have this presentation today. We got some we're excited to have Jim share what he knows, and so there's industry leaders and got on the call here. So while we're kind of waiting for maybe a few last stragglers to this, just want to let you know I'm Ben Reeder from the RG Group. I joke and say I'm just the geek squad today. So I'm really here to facilitate everybody on the call, and so my expertise just lies on getting Zoom and getting everyone here today. So what I do like to do is I kind of flip it over to Pete Wehler with the RG Group, and Pete's our pneumatic specialist within the group as well as some other talents. But Pete, I'll let you introduce everybody on the call.
All right, sounds good. Thanks, Ben. Appreciate it. So thanks everybody for taking some time out of your valuable time today. Again, this is certainly hopefully you guys will find this as a very rewarding webinar that we're going to share with you today. A lot of great things, a lot of cutting edge technology that Jim will share with us today. So again, Industry 4.0, Internet of Things, IOLink will primarily be the items that we're going to chat about today. So joining us on the call today is Matt Woolley. He is the local Parker Pneumatic Territory Manager. And also Jim Seery will be the gentleman who will be leading the presentation today. So Jim is the Senior Automation Controls Engineer with Parker and was certainly instrumental in the development of the new Parker PCH portal. So during the presentation, what we will ask is that you please hold your questions until the end. Myself and Matt will be monitoring the chat boxes. So certainly if questions do come up during the presentation, please feel free to put them in a chat box, but we will also give you an opportunity to speak at the end of the webinar. So without further delay, Jim, feel free to take it away. Thank you, sir.
Okay, thanks, Pete. Like you said, we're going to be speaking about Industry 4.0, basically how that leads into the industrial Internet of Things, how that kind of plays into IOLink itself. Just give you a little background. I've done controls for a long time. I've been with Parker for only a year. Prior to that, I was with Balluff, very heavy into networking architecture, IOLink, RFID and vision. Did a number of years with General Motors as a controls engineer, and then other positions as industrial engineers, mostly field type stuff, but been around for a long time. Before we get started, we wanted to just get basically a feel for basically you participants as far as Industry 4.0 and the industrial Internet of Things. So this is just have you ever heard of Industry 4.0? You've heard of it, haven't done anything with it, just familiar with it. Basically, your company's in the initial phases of basically putting stuff together, basically talking about it, at least putting thought into it, right on through to have you actually initiated any projects, possibly on a trial basis, beta sites, possibly, or basically kind of an all-in. Yes, we're a company that we try to get as much data, mostly diagnostics, that we possibly can. So right here, just the quiz popped up. Yep. You can all respond to this. So click your responses here, and then you can basically submit it. And I'll give you a second to do that, and then Ben, I'll wait for you to respond here.
Yeah, this is good. We appreciate everyone doing this. This kind of helps, helps direct this presentation a little bit better for those who are, different levels and different positions. Since we have a smaller group today, this is perfect. We thank you for that. And there we go. Just give it a few more seconds. It just gives you an opportunity, so you don't feel like you have to feel like you're pressured on this or anything. But all right, I'm going to end the poll so we can move it along.
Okay, Ben, does it show results or? Oh, there we go.
There you go.
Okay, so nobody's all in yet. Nobody's actually even initiated anything. So basically everybody's in the discovery phase by the results of the poll. So either haven't heard of it, have heard of it, or discussing it. So great presentation today then to kind of give you a little more background on what it is, how it plays in. Industry 4.0. It is a buzzword, but it does have meaning. The first industrial revolution basically was steam power. Back in the late 1700s was when that was used. That's what they're considering the first phase. The second phase is mass production and the assembly line. And an interesting note there that most people, when they think of the initial or the first production lines, they think of Henry Ford, basically in the automotive industry in Detroit. Actually, it was actually a slaughterhouse in Cincinnati that is credited with the first assembly line in the late 1800s. The third industrial revolution is the introduction of PLCs and electronics. It says 1969 into the 1970s. Basically, that changed the way automation was being done, controlled, data collected, predictive preventative maintenance, all of that. But that was the third industrial revolution. And then we come to today. But basically is the fourth, we're considering the fourth industrial revolution. And it's the cyber physical systems, the connectivity of things. It's networking, and then you think networking, well, that's been around for a while, but it's basically the networking of everything, not just taking place within the plant, on the plant floor. It's basically connecting everything. It is referred to as the fourth. Basically, it's a German directive, which was promoted the computerization of manufacturing. And again, data exchange with the cyber physical systems, cloud computing. Basically, it's the connectivity is the biggest thing. The fourth industrial revolution, basically what has come about are mega trends. You think about customization, small batches. You think about going to a store, not picking something off the shelf, but you go purchase a car. You go, and maybe it's more online where you're checking boxes. But basically, it's getting something that I want the way I want it. And that's the individualization. The world is becoming flatter. The competition is increasing. More flexible, smarter factories. And with the smaller batch runs and the customization, basically you need flexible tooling. And then basically data-driven decision-making on the fly, driving the need for increased communications, quick communications, and then we get into the data collection as well. It all plays into, and I'm going to touch on this here as we move on, but the aging equipment. And I've got some data to kind of show where that's at, and basically how that's going to be leaving the market soon, just because of the age of it and what's going to be replacing it. So here are some stats that are talked about when people are talking about Industry 4.0. There's $65 billion of automation reaching end of life. That's what I was referring to. That automation has to be replaced. So what's it going to be replaced with? 1938 is the average age of the equipment in the US industrial space. 4 in 10 manufacturers have little or no visibility to their actual process. 50% of manufacturers are only aware of a problem when it basically hits them in the face. When it takes them down, production stops, then they know there's a problem. That's a big number. And then as far as the investment part of it, less than 5% of revenue is being spent on investments and on capital equipment itself. What we do is we look, I just wanted to kind of make a point here, is you think about traditionally, there's a pyramid when you look at automation from the floor level. We'll take a look, I mean, think about it as at a sensor level, right on up. Things didn't go right to the top or bypass layers. It had to be passed. So basically sensors were tied to PLCs or robots. And then basically there was a backbone to where it would go on up to a process control level. And basically then you get up basically to a database that's driving production, build sequences, whatever it may be. To the right, basically it's taking those field sensors and connecting to anybody. Basically, it's abolishing this traditional pyramid to where there's no need to pass information through a structure. And I touch on this in a little bit as well. Just a little bit of information that I dug up. I couldn't believe this at first. You look at the number of variants of a Nike Air Max shoe, and I was blown away. I couldn't do it. So I actually went on and started Googling to see if this could even be close. And I didn't do the numbers, but I stopped looking because there were so many. But this gets into the individualization, the custom orders, but what it gets down to is flexible automation. Mercedes, over 200,000 variations. Again, as one car follows another car through the build process, it has to be very flexible automation. Basically, you think about Industry 4.0, it's the communications of equipment. What plays into that is the industrial Internet of Things. And that's where I'm going to kind of refer to it here as IIoT, as just an acronym, but it's actually a piece of the Internet of Things, which is more of a commercial term. And I'm going to show a slide in a second, talk about that a little bit more, but basically the industrial Internet of Things is the industrial piece of the Internet of Things itself. So the Internet of Things. This is going to be as time goes on. I was asking this. I've been asking this question for a number of years now. But it's who. And actually, if I was we were all together, could see each other. I could do a show of hands, a little bit easier. A little more difficult with this format, but it's how many people have their thermostat, tied to the network, or can access it remote of the house. Security cameras, or just cameras in general, your doorbell. These are things that more and more people are getting used to. But now you take it to your refrigerator, your toaster, your dishwasher. I mean, this is the Internet of Things. It's everything being connected. So the industrial Internet of Things, it's simply that connectivity that you think about where everything's talking to everything, where everything is accessible, but in the industrial space. And again, this is kind of a traditional pyramid to where you think about how automation is driven, and there's usually a database. And again, you've got basically a backplane of how that information gets down through routers, down to the plant floor, ultimately to PLCs. Normally robots, I'll throw those in. Those are usually controlled by PLCs, but many variations of automation. And then below that, you've got basically networked hardware down to the lowest level, which is your sensors. What we're just going to focus on basically are these bottom two. We don't, once you get above that, we're not getting involved in what's actually done with the data. But the critical thing is that it's data, data, data. And sensors play a critical role in that. The sensor, if you think about it, that's the thing that's actually collecting the data itself. That's the indicator of where the process is, what may be wrong, status, whatever it may be. And then once all of their data, which is the T of the things, is connected online, which is the I, then you can actually take, in there's packages, there's companies that specialize in what to do with the data analysis itself. I talk to people and some people say, you know, we collect a lot of data, but to be honest with you, we collect so much, we don't know what to do with it. And obviously there's an expense there, and that's basically a waste of resources, because if you don't actually do something with it, there's really no need to collect it. So basically it's collecting it and using it to your advantage. Industry 4.0 and IIoT Ready, basically that kind of a stamp. Manufacturers are using it as a marketing tool. And then you think about if a company is just connecting things, is that good enough to say that, yeah, I'm Industry 4.0 and IIoT Ready? And it's absolutely not. There's definitions of this connectivity and what you're doing with it. One of them is condition monitoring. And again, you think about it, a sensor level. Condition monitoring is looking at temperatures. It could be looking at humidity. It could be looking at vibration. It could be looking at voltage levels, voltage spikes, whatever it may be. A lot of sensors, smart sensors nowadays, have some type of condition monitoring built in to give you that feedback. It's automatic configuration, getting back to the individualization, the flexible automation. You have to be able to configure and reconfigure on the fly. And then the configurability beyond the PLC itself, and kind of where we go with that, and I go into a little more depth here in a second, but it's basically bypassing the PLC. So it's basically doing configuration or having configurability without the PLC involved. Basically, airproofing, been around a long time, but obviously airproofing is taken to a new level with the smart sensors that are available. And then also expandability, scalability. If you have to add, normally people think about model changes. A big one in automotive is, you know, a new model year. What's different this year from last year? And it's not always a platform change. It could just be trim. It could be minor stuff, but all the tooling has to change right along with it. That's the scalability for the future. And then we're going to kind of get into how IOLink plays into the industrial Internet of Things, right on up to Industry 4.0. So basically, just to get a feel for where you are with IOLink, and right on, you know, kind of should have started with, I've never heard of IOLink, but we still hardwire our machines, our IO, our sensors. And again, I haven't heard of IOLink, or we've talked about it. We've heard of it. Maybe somebody's come in and talked to us about it, presented it, but still haven't jumped on the IOLink bandwagon, or right on down through. Yeah, we feel it's advantageous. We're still doing our due diligence and feel free to answer the quiz here. But basically that you're using IOLink in select applications, right? Or basically, you know, we have jumped full in. We use IOLink everywhere we can. So take a couple minutes there. Go ahead and fill it out. And then Ben, you can jump in with the results.
Absolutely. Yep. Coming up. Very interested to see. We have a very, again, a broad spectrum a little bit. There we go. All right. And the poll. There we go. Let's share the results.
Oh, nice. Okay. Well, in the first quiz, it was very top loaded. So in the industry 4.0 and the industrial Internet of Things, obviously not a lot has been done. But so with IOLink, there are a couple that haven't heard of it, some that have considered it, maybe evaluated it, maybe done some bench testing, and we do have people that are actually using it, which is great. On select applications. So that's great. So what I'm going to do here then is basically just get into IOLink itself. This isn't going to be a tutorial on IOLink. It's more of just an overview of what it is, its benefits. But IOLink, by nature of what it is, and we'll get into it, is it fits right into the industrial Internet of Things. You can look at, actually, not to get off script here, but actually what IOLink is, it's basically a low-cost point-to-point communications. I'm going to kind of jump to the bottom one to where it's not a network. And what everybody has to understand is when you consider IOLink, you're not being asked to change your PLC or that platform or your field bus. A lot of companies standardize, whether it be Profinet, Ethernet IP, EtherCAT, depending on the applications. Some of it is PLC driven. They've got their Virgin field buses, and that's okay. IOLink does not replace any of that. It actually plays below that. It actually requires a field bus. And so basically it's a distributed IO architecture that resides below the field bus. But what we use an analogy as called industrial USB for three reasons. One, everybody knows what USB is from their computer. And you know that USB is an open protocol. So just because you've got a Dell PC doesn't mean you go buy Dell USB devices. You just go buy anybody's USB devices. That's the open protocol. The plug and play. When you plug in a USB device, you don't set a node, you don't set an IP, you don't set a baud rate. There's no addressing at all. All you do is you plug it into your computer. Some people say then it just magically works, but obviously you need a driver in your PC, just like in an industrial application, in the PLC or the robot, you need something that supports what you just plugged in. But the physical plug-in is just plug and play. So from a maintenance standpoint, again, no addressing. They just take it off the shelf, out of the crib, off another tool, whatever it may be, and plug it in. The other part of the industrial USB analogy is that it is a serial. USB is serial. People that have been around for a while, and they remember the old RS-232, 45, the RS-422 applications. People would think, why do I want to put serial out on my machine nowadays? The big reason is that even though it's serial, it's at a 24 volt level, not a 5 volt level. And the amount of noise it takes to disturb a 24 volt peak-to-peak signal relative to the 5 volt, it's exponential. So it basically makes IOLink virtually noise immune. And then we already talked about the fact that it's not a network. This just goes through a little bit of evolution of basically you think about connectivity, right from hardwiring sensors either back into a panel through a cord grip or a bulkhead to a terminal strip on up to an IO card in a PLC, or same thing in a robot enclosure. And then basically that getting replaced with distributed or networked IO. So where now basically you're plugging your sensors into a field bus module that's directly connected to the field bus. Then you get to IOLink. And so what IOLink is, it's comprised of a master and the IOLink devices. The IOLink devices are going to be the same ones that you've been using all along, except that instead of having a discrete interface, it's going to have an IOLink interface. No more cost, and we'll get into that. But basically, you're connecting that to a master, an IOLink Master module, which that is the field bus module. But what normally would have been connected to the field bus or just discrete wiring is now connected through the master. You think about a master as a gateway, and one of the definitions of a gateway is a conversion between two protocols. And in this case, it's whatever your field bus that you're utilizing in IOLink. Okay. This is basically IOLink architecture. Upper left, you still have a PLC, and this could be a robot. I didn't mean to leave out those applications. You've got a power supply. Those are still normally in panels of some sort, although a lot of things are being converted to IP67. People are trying to eliminate or reduce panels. So basically then you're getting out to the IOLink Masters. You're getting out to either the network modules, sensors of some sort, pressure sensors, linear encoders, lasers, ultrasonics, whatever kind of sensors, right down through to prox sensors or whatnot, which are normally connected still to your IO hubs, your IO blocks. Cylinder switches, instead of getting a discrete work home or extend retract signal, you're actually getting an analog representation of where that cylinder is. This is all basically smart technology, and that's what IOLink is all about. That's why it fits so nicely into the industrial Internet of Things. The data collection part, today we basically kind of talking about data. Traditionally, sensors would come up to a network module, maybe, and again, all the way back to hard wiring, basically wired into a panel, terminal strips up to a card, but ultimately they were funneled through a PLC. The PLC would then be tied to the network. Whatever protocol was used up there's many of them, but basically it's going to get up through the backbone, up to the databases. You would have servers, applications at that point, either analyzing it or whatnot, but then you've got the user that's actually utilizing that information. Now with IOLink, you can actually, and also going back, what I didn't mention is basically when you're funneled through the PLC, everything that goes through the PLC impacts the performance of the PLC. And that's huge because it's taking up memory, it's taking up processing time, the scan time it's referred to of a PLC. Nowadays, you can actually bypass that PLC. It doesn't even, when it comes to the data collection. Now, we got to be very careful here, and I've got my next slide that kind of touches on this, but this is not control. So what it doesn't mean is that somebody can sit at home or in a front office and control, actually they can, but the intent is not to control the plant floor. It's just collecting data, it's monitoring that data, and it's making decisions based on that data. And so then, basically, this is just kind of a flow. So basically, you've got in the upper right there, you got the database. Now, as far as control, he may be doing a build sequence, a production schedule, whatever it may be. He's going to pass that down to the PLC, possibly robots, whatever it might be, but basically to the PLC. Then the PLC comes down to the field bus modules, to the basically which is passed right through to the sensors themselves. That's actually controlling the process. But the capture of the data, if you notice, that's the green line as opposed to the red. The collection of those sensors, it goes through the master. It does not go through the PLC and goes right back up to the database. Many different forms of the database. I kind of just summarized it like that. But basically it's data collection on up off the plant floor, bypassing the PLC and therefore not impacting the PLC. Then with IOLink, just to get a little bit more into the particulars, we've kind of been talking about how it plays into the industrial Internet of Things and Industry 4.0. But then we want to kind of look at, do a little deeper dive into IOLink itself. And so one of the obviously important to anybody is where's the cost savings? And with IOLink, it's from one end to the other. In the design phase, normally when you're laying out electricals, if you're doing hard wiring, every conductor you have to label, you have to route, you have to land. And with IOLink, you're using molded cables. And so basically you're taking 4 or 5 conductors that you would have labeled individually, routed individually, landed on a terminal strip, whatever it may be, and it's just a cable definition now. So now it's basically a 4 or 5 to 1. And insofar as templating IOLink, it's actually a lot easier to template than it is custom hardwired drawings. In the build phase, when you're actually putting this together, you can basically deploying, commissioning this hardware, instead of routing and landing individual conductors or multi-conductor cables, either through panels to terminal strips, it's just connecting connectors. It basically is what it comes down to, which leads itself right into basically buy off, right into the automation part of it, or running. Basically, as far as debugging, if you're just connecting a cable as opposed to landing individual conductors, your debug time is going to be cut down significantly. So you think about what actually goes into a traditional panel, and I have a phrase there. It's so much effort, and you get 0 diagnostics, because all you're getting back is binary data from the sensors. There's nothing more than that. Then we look at cost savings, which this is huge. I do have to preface this by saying that, IOLink is not a one size fits all. It's not it's not the best solution for every application. Just like any technology and any hardware, on smaller machines, smaller tooling, because you have to basically buy the master, it may not work, but it doesn't take much, and depending on what your application is, that basically you recoup the cost of the master. Because when I talk about IOLink, the master, which you have to pay for, really doesn't buy you anything. Because it's a gateway, it's just collecting things and passing them on through. You have to justify the cost of that master, and that could be $300, it could be $600. They vary depending on the size, capabilities, what they're made of. A lot of things come into play, but basically you have to justify that cost. And how you do that is you're paying less money for the IOLink equivalent of the field bus version of it. So you think about a field bus module, 8 ports, 16 points, very traditional. If it's an Ethernet IP or a Profinet module, I like to throw out that you're roughly $300. Well, you can buy the IOLink equivalent of that for $100. So if you only have one of them, well, you just save yourself $200. You haven't paid for your master. But if you have 3 IO hubs, you've paid for your master. But that's when you just break it down to a discrete IO scenario. But if you're looking at RFID right away, it's huge, because you're normally paying about $1,500 for an RFID processor that gets eliminated. And now you buy an IOLink RFID head, connect it to the master, and actually I have $1,500 versus $400. You still, even with an IOLink or an RFID processor, you still have to buy the read-write heads. So you're buying the IOLink version of them, but the processor goes away. Analog. Actually, I touched on that in a second. But as far as the networking cables, the power cables, these are expensive cables because they're not on the field bus. Now you're connecting it with either a 4 or a 5 conductor, You know, I throw out tool cord, sensor cord, prox cord. Everybody kind of calls them something different, but it's a 4 or 5 conductor unshielded cable, which I threw a value up there about $10 for that, as opposed to $100 for an Ethernet or a Profinet M12, RJ45, whatever it may be, cable. But you're saving money in those as well. Reduced panels, even junction boxes can be eliminated. But you're saving, because you're getting stuff out of panels and out of boxes, you can reduce the size of those. The elimination of hardware, analog, when you have analog applications, normally you would have shielded cables out to whatever your analog sensor was. You've got induced noise, issues that you have to deal with, the routing of the cables, but all the way on up to you're plugging it into an analog module in the PLC. Well, that module can go away, because now you're going to buy an IOLink version. And if you haven't gone looking, you'd be surprised by how many sensors that you may have and not using them as IOLink are available in an IOLink version. And for usually it's for the same price. You're not even paying more money for the IOLink version of the same sensor. So you think about a laser, you think about an ultrasonic sensor, a linear transducer. These are all very traditional analog sensors or devices. And now there's IOLink versions of all of these. We talked about the RFID processors and what you're eliminating there. Thermocouples. You have thermocouple modules in PLCs that are expensive. There are solutions out there for thermocouples into a thermocouple module. It's an IOLink module. And again, we talked about the Ethernet and the power cables. Just kind of threw some numbers up there as far as what can be eliminated. And junction boxes, a lot, can traditionally just be eliminated as well. Labor, a little tougher to put numbers to, because it's geographic as far as labor rates, obviously. But basically these intangibles, but most companies, if not all companies, do have a cost per point to land a cable. And when you're basically taking that to basically screwing on a connector to landing four conductors at both ends, it adds up, and it can be huge. As far as the commissioning, you think about the tools built, it's bought off. You've already gone through everything we talked about as far as routing the cables. But when you go to break it down, all that's got to be detached, taken apart and shipped and put right back together, which at that point, all the build phase problems just repeat themselves. Is kind of what I'm pointing out there. So we look at what are the advantages to IOLink. It is widely adapted. It's actually, this is one of those things that the Profi community actually governs it. And they like to do graphs that take years along the x-axis and the number of nodes on the y. And they started with a Profi bus, and it's an exponential. So as time goes on, as far as the usage, it just increases exponentially. They did the same thing with Profinet. They're doing the same thing with IOLink. The curve looks identical, and it's an exponential curve. As time goes on, it's just the acceptance and the use of it just continues to increase exponentially. But you look at the products in the market, and this by no means is all of them. But these are ones that are traditionally used. A lot of people can relate to pressure sensors, temperature sensors, and these are all available with an IOLink interface. Measurement, you got linear transducers, lasers, ultrasonics. I've been mentioning color sensors you can get color sensors on IOLink, RFID, valve manifold control, which is actually what we're going to be talking more about here in a little bit. Discrete, which is your very traditional discrete IO modules, and then analog itself. And I did mention a lot of the sensors that were traditionally analog have will come in an IOLink version of that. But if it by chance doesn't, there are IOLink to analog modules. So you still don't have to buy the PLC analog card. You still don't have to route the shielded cables. Be concerned about that. The induced noise issues and whatnot. You can buy an analog IOLink module, put it out there as close to the source as you can physically get it to reduce that analog length of cable down to almost nothing, hopefully. And then it's IOLink, virtually noise immune. Okay. We've been talking about condition monitoring from the very beginning. We talked about this, but this is what IOLink smart sensors provide. Basically, they're going to give you information about themselves. Basically, voltage, current levels, temperatures, humidity, vibration, short circuit detection, overload detection, cycle counts can be maintained internal and not done in a PLC or a robot enclosure. Automatic detection and identification. You think about the traditional sensor. You didn't know if it fell off, it got cut off. Somebody took it off and used it somewhere else and didn't replace it. With IOLink, not only do you know if an IOLink sensor is connected, you know exactly what IOLink sensor is connected. So now in air proofing in the PLC, you can actually put a diagnostic up there that there's a port mismatch at whatever master, whatever port, the correct IOLink device, or just in this case, the correct sensor is not connected to the right port. So basically, it's just that intelligence being built in. Automatic configuration. When we talked about industrial USB or the analogy of the industrial USB, and it's all plug and play, which when maintenance goes and replaces something, basically they just plug it in. Well, what can happen, this is something that does have to be set up, but the functionality is here to do it, to where on connect, any configuration or all configuration of that device is downloaded right to it. So you think about a pressure sensor. Normally maintenance has to use the little toggle buttons on the sensor to set the set points, maybe the units, could be scaling, hysteresis. There's many things, orientation of the display itself. Now he just plugs it in. All that information is automatically downloaded to it. Okay, so that's huge. More IOLink advantages. Again, it is a serial bus. It is at a 24-volt level. We did talk about that. And again, virtually noise immune. The only applications that I've run into that were a concern are in welding applications. And it's not even the resistance welding, the spot welding. Those are not long enough cycles to interfere, but the MIG and TIG type welding applications or the continuous welding applications, you have to be very concerned about your welding or your power cables and your separation to your low voltage or your COM cables. And so there are some applications, there are solutions for it out there. Manufacturers have addressed that. But other than that, and normally it's when you can't separate those cables. Even in those applications, when you can separate them, it's not an issue. But just a handful of applications, but again, they are taken care of. So for the most part, we say that IOLink is virtually noise immune. And it uses an off-the-shelf, basically prox cable, tool, cord, sensor cable, whatever it might be, whatever you guys call these multi-conductor unshielded M12 cables. By spec, you can go up to 20 meters, approximately 65 feet. So basically a 20-meter cable between the master port and the sensor itself. So there is a limitation there. Usually that's more than enough to centrally locate a master and distribute from there, but that is a requirement that does have to be met. So then what we do is we get our commercial break here and we get to talk about the Parker's PCH network portal. And what's unique about this and why we've kind of been tying all this into the Industry 4.0 right on down through the industrial Internet of Things, right on down to IOLink, is this is a 12-port IOLink Master. And it is a head module for a pneumatic manifold as well. This has actually been in development for a while. We do support 4 field buses, Ethernet IP, Profinet, EtherCAT, and Modbus TCP. Basically, we did a market analysis when we were developing this or prior to developing it to get a feel for, in most applications on IO that's going to be tied to a manifold, what is required for a typical machine. 24 points is what 85% of the customers came back with. That's what kind of drove the 12 ports. But that's if they were only used as discrete. And I'm going to get into the kind of the configuration of this between discrete and IOLink configurability. But this is just information that we used that kind of drove the design of this. And users still use a variety of IO. That's kind of what drove the IOLink functionality with it as well. So what we did is we kind of came up with a port design that we like to call true port configurability. So basically out of the box, it's a discrete IO point. And also what's unique to this, unique to Parker in this sense, is that based on a configuration, you can configure an input as a PNP input or an NPN input. With anybody else, it's actually another part number. It's a different piece of hardware, and it's either going to be an all or nothing to where the module, which is traditional anyways, it's either all NPN or all PNP. But with this module, with the PCH portal, you can actually take pin 2, make it an NPN input, and take pin 4 and make it a PNP input, and right on the same port. So that's part of our true port configurability. And then you can also enable it as IOLink because it is an IOLink Master, but you have the choice of doing that. Some of the features we like to talk about is we have tested this in welding applications. The housing itself is splatter resistant. You get with this electric and pneumatic zoning, which I'll touch on a little more in a second here. Safe power capable. This is not a safety device. It does not have a safety rating, but it's safe power capable. What that means is that your input or your logic power is galvanically isolated from your output or your auxiliary power, which is required when you've got safe and non-safe power that don't share a common. And then also it can handle test pulses of safety circuits, and that's why we call it safe capable. It does have Bluetooth capabilities. We're getting mixed feelings on that. There are people that's they want to stay away from Bluetooth on industrial hardware. This is triple password protected, so it's not like somebody can walk by with their cell phone, jump onto via Bluetooth onto this and control automation. By no means, but it does have Bluetooth for the convenience of primarily commissioning, forcing IO, maybe exercising cylinders, whatever it might be, looking at status. It has its advantages, and it can be done via a Bluetooth connection. And then it does support up to 32 ISO valves. Power, we have different configurations for the power on it. It's traditionally 7/8 power. We do support the 8 power, more the European standard. But it comes in 4 and 5 pin. If you dealt with the different field buses, normally Ethernet IP is a 4-pin standard. Profinet, EtherCAT, Modbus is a 5-pin standard. Normally when you buy a field bus module, it's already determined what, the connector, whether it be a 4 or 5 pin. With this, it's actually configurable. So you could actually get Profinet with a 4-pin or Ethernet IP with a 5-pin, which normally isn't desired, but you do have the ability to do that. Safe power zones, I'll touch on those in just a second here. I think it's my next slide here. And this is just one slide out of many we normally show, but this is a configuration to where instead of the traditional power in out, which is a power option with the PCH portal, but we also have a power option to where it's power in, and you can actually have 2 power zones out on your manifold. You'll see the spacer between the 2 zones that can move. You can have up to 24 valves in your first zone and up to 8 valves in your second zone. But again, you can move it. You can have 4-4, 8-8. You just can't have more than 24 in the first and more than 8 in the second. But that is that is an option for us. So zoning, whether it be pneumatic, pilot pressure zoning, or the electrical zoning, we feel we cover it all. We talk about diagnostics, and again, with data, which we've been talking about all day today. With the portal, we feel we went overboard on diagnostics, but you can't do that. Diagnostics they're used by or configured by the user. We make them available, but for a controls guy to take a point, push it to a PLC or to an HMI, possibly up to a database, text somebody, email somebody, whatever it might be with that diagnostic. Configuration time does have to take place, but we make a lot of diagnostics available, and then the users can choose what they want at that point. So that is the PCH portal. That kind of wraps up, basically the presentation. So again, Industry 4.0, where we are with that, and why we call it Industry 4.0, how the industrial Internet of Things plays into the Industry 4.0, and then IOLink, and how IOLink plays its role into the industrial Internet of Things. And the PCH portal is an IOLink Master, basically tying a bow around the whole thing. So that's what I've got. I'll throw it back to Pete and Matt at this point, who are your contacts. So if you're looking for information, please don't hesitate to reach out to them.
All right. Well, Jim, I really appreciate it. That was a great, in-depth look at, Industry 4.0, IIoT, as well as IOLink. Did have a couple questions come up. First one was, so how does the PCH portal uniquely solve IIoT challenges? So
that's a great question, Pete. And that's basically being an IOLink Master module tied right to smart sensors. That's basically what IOLink is. It's not your traditional binary sensors. It's a smart sensor. You're collecting, basically condition monitoring, information from it. You've got configurability, parameterization. All that ties into the flexible automation, the individualization of what Industry 4.0 and IIoT is all about. And we are a gateway right down onto the plant floor for that.
Okay, awesome. Another question that came up is, it says, do you have to perform a PLC download to add an IOLink Master to a PLC device tree?
The answer to that is no. Depends on what PLC that you're referring to. I'll just grab one out of the air and talk about a Rockwell, compact logics, control logics. You can actually do this configuration. So depending on how you're doing it, you can actually do that online. But when you configure in the IO config of a Rockwell, you insert an Ethernet module. The PCH portal configures no differently than any other Ethernet IP. You can use the EDS file. You don't have to. You can do a manual configuration. We have add-on instructions that basically take that whole defined interface, hand it to you. So all you have to do is use the whole tag structure in your data table. So it makes the integration and the configurability very painless. So.
Awesome. Okay. So, and last question that I came up was, says, so what is unique about the PCH portal? I'm guessing what's different about the Parker portal that's sets it apart from other folks that are out there?
Yep, and actually we do have competitors, obviously. One of the things we like to talk about is one part number versus many. If you looked at the module, it is a fixed structure. It's not a slice structure. So what might take 12 part numbers to build up between your modules, your end plates, your brackets, whatever it might be, it's one part number. Could be pros and cons to that, but the configuration of it, which includes the field bus option that it's going to be communicating at, the power option itself. And also we didn't get into, I did intentionally not get into IOLink too deep, but there's two types of IOLink ports, and this is not a Parker thing, it's an IOLink thing. So everybody who puts a master on the market has either type A or type B ports. And so we have that as well, and that's actually built into the part number. But once you configure that part number, that's the part you get, it's one part. The other thing is the Bluetooth functionality is we feel is unique to this master, and also the NPN PNP. That configurability is very much unique to Parker. So it does have advantages that other people don't provide.
Okay. And then Robert just asked, is there any way to extend the 65-foot limit?
That unfortunately is, again, it's not a Parker thing. That is an IOLink specification. So there is a spec. So anybody that's going to put a master or a device out there, that's the spec that they put out. So unfortunately, Parker has no control over that spec.
Okay. All right. let me just double check here again in the chat. Nope, I don't see any other questions that, how about wireless sensors? I guess the question is like, what's the distance that could be used for wireless?
Yeah, no, that's another great question. That does come up as well. Wireless IOLink is, it's being talked about, but it's actually a little bit more than that. There's not much out on the market for wireless IOLink. It's a lot like wireless field buses too, wireless Profinet, wireless Ethernet IP. But no, unfortunately, the PCH portal is not a wireless IOLink master.
Okay. All right, I'll just give it another second here, see if any other questions pop up.
I've also gave the ability to unmute everybody. So if anyone actually wants to talk, they can unmute themselves and ask a question if they'd rather do it that way.
Oh, great. Thanks, Ben. Appreciate it. Sure. We'll give a few, another minute or so here for questions if anything pops up. And certainly in the meantime, while we give some folks an opportunity to ask some questions, as I said, Matt Woolley is also on the call with us today. But Matt and I are available to come on site or virtually in this world we're all currently living in. We can either do virtual or on site demonstrations of the PCH portal. So again, we tried to give you enough information today to help you to understand basically kind of what the PCH portal is. But if you want to have a more specific discussion or demonstration of the PCH portal and how that would better fit into your particular application, I understand certainly everybody's gotten my contact information. That is also up on the screen as you see. But also this presentation will be recorded. I'm sure Ben will be sending some information out, but please don't hesitate, reach out to me. Feel free to give me a phone call or an email. And either Matt and or I are happy to, again, do an either virtual or in-person demo for you. I did not see any other questions come up. So Matt, is there anything that you would like to have to say before we close out, sir?
Hey everyone, just wanted to introduce myself so I'm not just a name on a screen. I do have a shiny demo like Pete said that we'd love to take to your facility and show you, or we can give a presentation online. But other than that, I got nothing else to add. So.
Okay, well, Matt, certainly appreciate your time and joining us today. And Jim, we greatly appreciate all of your information and expertise. That was a really great dive and look into this new and emerging technology. So again, thank you very much, Jim. I appreciate it.
You're welcome.
I'm going to kick this back over to you, sir. Thank you.
Thank you. So everyone, this was recorded. So we're going to be sending out emails after this with viewing the recording. So if you find this valuable or you want to pass this along to someone else, I'm basically uploading it to YouTube and then using that as a link to send out. So certainly love to share that. But if you have any questions, I'll be sending an email out as well, just kind of with contact information, so and so forth. So, but we really value your time and appreciate you being on the call with us today. And hope you enjoy the rest of your day and happy Easter to everyone for this weekend.
Thanks, everybody. Have a great day.
All right. Take care. Bye-bye.
Okay.